Cool. Now, can you guys see my slide presentation there?
Yes.
Beautiful. Yep. Rightio. We got a few people joined in already. That's pretty good. Give them another minute and then we'll kick off formally, I think. One of my Victorian colleagues used to have the ABC rural radio playing in the background at this stage. I haven't quite worked out how to do that yet. So we'll see how we go. Cool. Rightio, we might start, people. We all right to go? Excellent. Hey, welcome everybody to this weather webinar, and just a few housekeeping things and a little bit of introduction. If you're at home and you got your computer there, can you make sure you have your mic muted just in case there's some background noise? Feel free to put your video on or off, whatever suits yourself. If you would like to communicate with us and ask questions during the presentation, please use the chat facility, which if you're on Teams, which we all would be, it's the little dialogue bubble, top left-hand corner of the icons row there. So please use that. We might, towards the very end, once the presentation is over completely, we shall have some Q&A if you want, if you haven't already put your question in the chat. All the presentation slides are numbered, so if you note the number of a slide that's of particular interest, we can get back to that and get back to you. On that slide there, second line there, if you do have any issues, you get dumped out of it and you can't get back in for any reason, please give Jess a call on that number. I'll give you a moment to take that down or take a photo, however you want to remember it. So what are we up for tonight? So the genesis or the origin of this webinar is a couple of landholders and farm managers were having a discussion one day, and there was a little bit of a conversation around some of the fundamentals about what we actually see on weather maps and how we interpret some of that stuff and what that might be telling us. So we're going to cover a few fundamentals there, a little bit about clouds, always very interesting, and then move on to weather forecasts and short term and how they're interpreted, but then move into some a little bit more sophisticated tools with climate outlooks. And our esteemed presenters, Jenny and Jennifer and Kim, are going to dive into that for us. And we'll have a look at the end on the current conditions. Our presenters tonight, Kim Broadford and Jennifer Wurtzel from what was DPI, the Department of Primary Minister Regional Development now. And as you can see, they're both from a fairly, would you say, specialised team, Kim, dealing with this sort of stuff? And
yeah, absolutely. Only a couple of us as well.
Yeah, exactly. So those are our presenters, and I might jump off there, Kim, and hand over to you.
Excellent. Thanks, Paul. And we'll just let Jen start screen sharing.
Yep.
Might have to. Right. So while I sort myself out.
And don't forget, people, if there is a question you have, the slides should be numbered. So write that down on your notepad.
Nope. That's not
and then
it.
we can get back to it.
Don't look too bad, Jen.
Oh, was almost there. Sorry, it's not giving me little thumbnails to tell me I'm clicking on the right screen.
Oh.
Well, I might start while Jen's working on that. But yeah, thank you, Paul, and Jess as well for having us. So welcome, everyone. Jen and I work with the Department of Primary Industries and Regional Development in the climate branch, well, the Climate and Natural Resources branch. We are responsible for running the department's seasonal conditions and drought monitoring program. There's lots of aspects to this program, which we will run through in a little bit more detail later. But before we get started, I'd just like to mention that some of the topics we'll be covering tonight are the first time that we've presented them. So we'd be really looking for some feedback after the presentation. And certainly Paul will be able to help coordinate any of that feedback on some of the slides. Over to the first slide, thanks, Jen. So one of those news topics that we will be looking at is in the first section, and that is what is on a weather system, what is on a weather map. So yeah, again, please let us know if the information is useful. In this section, Jen is going to cover some of the things that you might see on a weather map, highs and lows, what are fronts and troughs, a little bit about the types of weather you might expect from these systems. Jen's also then going to provide an overview on the key drivers of seasonal climate forecasts that affect conditions here in New South Wales. She'll introduce the subtropical ridge and talk about El Nino, La Nina, and Indian Ocean dipole. I will then be jumping in and just having a bit of a talk about what we do, so the Seasonal Conditions Monitoring Program, and just give a quick update on current seasonal conditions. And then we can open up the evening for in-depth discussions. In interest of time, we will leave most questions till the end. As Paul mentioned, we do have the chat running, so please put your questions in there, and any specific ones we'll answer on the way. And also, as Paul mentioned, there's numbers on each of the slides, so we can use them as well at the end to refer back to anything. Okay, that's enough for that. I'll hand it over to Jen.
Thanks, Kim, and thanks, everyone. Hello. Sorry, just adjusting my mic a little bit here. Okay. So yes, I am going to start us off with a little bit of a review of the weather map. So first I'm going to set the scene here. You are watching the 6 p.m. news, and along comes your evening weather with your local meteorologist, who starts pointing to a map like this and rattling off information about cold fronts bringing showers and high pressure bringing settled weather and weak troughs generating patchy rain. So what are they looking at on this mess of squiggly lines and letters that's telling them what the weather is doing? So on this map alone, you have isobars, pressure systems, fronts, and troughs. So we're going to now go over a few of these in a bit more detail. So here I am showing a similar map to what you might see on the news that you can get on the Bureau's website. This is sometimes called a synoptic map or chart, basically meaning it's a large-scale overview of current conditions. We've got all of our squiggly thin lines here with numbers around 1,000. And these are our isobars, which are lines of equal pressure, iso meaning equal. Pressure in this case is atmospheric pressure at sea level or mean sea level pressure. And these are measured in units of hectopascals, which are numbers, these numbers that are around 1,000 all over the map. Now, standard pressure is usually 1,013 hectopascals, but pressure is all about relative surroundings. So we will come back to high and low pressure in just a second. Isobars do tell us a lot about what's going on with wind and airflow. As a general rule, closer isobars usually mean stronger winds, and you'll often find those closer isobars and stronger winds around cold fronts and low pressure systems or cyclones. Conversely, the bars around high pressure systems are a bit more spaced and are associated with lighter winds.
Jen, before we go on, just a quick question. What causes the pressure?
Yeah, that's a good question. The atmosphere. The atmosphere has mass and weight, and that entire column of the atmosphere is pressing down at the surface, but it can have little variations at the surface, often due to things like temperature and altitude. As you go up, mountain, the pressure decreases because you have a little bit less of the atmosphere on you. So that is pressure in a nutshell. So continuing on the topic of pressure, on the weather map, you will have all these H's and L's representing high and low pressure systems at the surface. And those L's and H's usually have their central pressure value next to them. And just a quick note here, when interpreting these, some news outlets will show pressure, high pressure is blue and low pressure is red. Others actually reverse that. There is no standard convention. So when you are reading the weather map, pay attention to the letters, not the colors. So breaking down our high and low pressure systems, high pressure is marked as an H in the center of the system, and those values tend to be higher than about 1,020 hectopascals. Winds flow anti-clockwise and outward from the high pressure center. That is in the southern hemisphere. In the northern hemisphere, that would be reversed. In a high pressure system, air is sinking from higher levels. Sinking air is very stable, so high pressure tends to be associated with dry, clear, or settled weather at the surface. Low pressure is marked as an L. You can have shallow lows that are greater than 1,000 hectopascals. There's one on this map over the Australian continent. You can also have moderate lows or depressions in the 980 to 1,000 hectopascal range. A lot of East Coast lows seem to fall into that range. And then you can have intense cyclones or deep lows that might have pressures less than 980 hectopascals. So for example, the two tropical lows on either side of Australia in this map have subsequently become tropical cyclone Bianca, which hit a low of about 970 in the Indian Ocean and then dissipated without making landfall. And I'm sure we've all been hearing a lot about tropical cyclone Alfred. This is a bit early in its development, but it has since hit 960 hectopascals. It is weakening as it moves south towards Brisbane. Now, for historical reference, Cyclone Yasi in 2011 recorded a minimum pressure of 929 hectopascals, so it can get pretty low. The lowest cyclone pressure ever recorded, actually the lowest surface pressure ever recorded, belongs to Typhoon Tip from 1979, which reached 870 hectopascals during its journey across the Western Pacific. Now, in the Southern Hemisphere, wind flows clockwise and inwards in a low pressure system. That's that cyclonic motion that we see in these storms. And low pressure systems, as I think we've just established, tend to be associated with wet and windy weather, to put it mildly, due to the instability of warm rising air that occurs in low pressure systems. So a little memory device for this is high pressure happy weather, low pressure lousy weather. And it refers to that general relationship that high pressure brings that settled, I want to be outside type of weather, while low pressure tends to be, gray and stormy. There are a few caveats to this. For example, high pressure also tends to be related to heat waves, so maybe not always super happy. But high and dry is another way you can remember that relationship. So back to our weather map, next up is fronts. Fronts are the transition zones between two air masses, usually defined by their temperature and density properties. There are a few different types of fronts, but the main two are warm and cold fronts. Warm fronts are the leading edge of warmer air that is moving into cooler air, and they are represented by red lines with semicircles pointing in the direction of travel. As you might expect, warm fronts can be accompanied by a warm temperature change. This doesn't necessarily mean sunny weather, though. As warm fronts pass over colder air, cloud forms and you get gray skies, steady rainfall, and humid conditions. Cold fronts, as their name suggests, are the leading edges of cooler air masses moving into warmer air. They're represented on the map by blue lines with triangles pointing in the direction of travel. As cold fronts pass through, they can be accompanied by a sudden drop in temperature, sometimes substantial, and gusty winds. Cold fronts wedge themselves underneath the warmer air in front of it, forcing that warm, moist air to rise. As warm air rises, it cools and condenses, or the vapor in it condenses, producing clouds and rain along that front boundary. Now, these upward motions of the warm air are a bit more vigorous than the rainfall associated with a warm front. So cold fronts are more likely to generate intense showers and severe thunderstorms, but generally along narrower areas than a warm front. So this is what you get, those long, thin thunderstorm systems are often associated with the cold front. So cold fronts are a defining feature of Australian weather across all seasons, a lot more common than warm fronts in Australia. And like in this map, they usually travel from west to east, with low pressure systems south of Australia drawing up cold polar air from those polar regions. Cold fronts in summer can lead to increased fire danger because you have that gusty wind at the front of the cold front blowing into these hot and dry air mass that's in front of the cold front. And this is actually thought to have contributed to many of Australia's worst fire events. Winter cold fronts also can bring damaging wind, heavy rains, and snow when the air masses are cold enough. Winter cold fronts are responsible for a large proportion of rainfall in southern Australia during those cooler months of the year. So here I'm going to take a brief interlude on clouds before going back to the weather map, because you don't necessarily see clouds on a weather map, but many cloud types are associated with the different frontal systems that we've just discussed. So for example, an early warning that a warm front is approaching is the formation of cirrus clouds high in the troposphere. And that's occurring due to that initial uplift of warm air. You're getting a little moisture in that really high part of the sky. So cirrus clouds are those wispy, feathery looking clouds. They're made of ice crystals because they're so high, usually around above 6 kilometers. They do not produce precipitation. Cirrus clouds can then thicken into cirrostratus clouds. These are also high altitude, they're made of ice, but they're more widespread like a sheet. The suffix stratus, which we're going to hear more of, comes from the Latin strato, meaning layer, indicating that blanket covering of clouds. Again, these don't produce any rain, but they may indicate the arrival of rain within a day or two. And now and then you may get lucky enough to see this prism halo effect, that kind of circle rainbow around the sun due to the way that that light reflects through these ice crystals. It's a very cool phenomenon. Next up is altostratus. Altostratus forms lower in the atmosphere than its cirrostratus cousin. The Latin prefix alto actually means high, but it's used in meteorology to refer to mid-level clouds. They are relatively higher than the low-level clouds that we haven't actually talked about yet. You'll recognize altostratus as that dull, light gray, featureless, overcast cloud. You can sort of see the sun through it sometimes. It can produce a light mist, but if the rain has hit the ground, it has already developed into its successor, nimbostratus. These are thick, low to mid-level clouds that can produce steady, moderate to heavy rainfall. They can also produce snow. Like other stratus clouds, nimbostratus are widespread blanketing sheet clouds, but these ones are so thick that you would not be able to see the sun through nimbostratus. Now, clouds associated with cold fronts tend to be a bit more straightforward. The wedging of that cold air under the warm air, as we discussed, causes warm air to rise rapidly and condense, forming cumulus and cumulonimbus clouds. Now, cumulus clouds actually come in quite a few different forms, and they're not always storm clouds or associated with fronts. You can often see these cute little puffs of cumulus humulus on fair weather days as they appear in the picture here over Cowra. And actually, I think they're kind of in the background of our screens as well, a bit of cumulus humulus, just so I can say that again. Now, when associated with cold fronts and storms, cumulus will start to grow vertically, becoming these massive cumulus congestus clouds, indicating strong updrafts, vertical motion of wind. Now, when the energy in these clouds hit a critical threshold and it becomes organized enough to generate rain and storm activity, it will then become classified as cumulonimbus. Now, from a distance, cumulonimbus can actually be quite difficult to distinguish from cumulus congestus, but you'll kind of know it's a cumulonimbus when you start feeling the strong wind, seeing the lightning, hearing the thunder, and dodging the hail. As cumulonimbus becomes organized, it may also produce other features such as anvil clouds or shelf clouds, which is actually what's pictured here. Now, there are more types and more subtypes of clouds that I haven't covered here, and we can provide some links to some cloud sites that we quite like if you want to learn more. But I do think it's important to point out here that cloud formation is very complicated. You look up in the sky, you're rarely going to see just one type of cloud, and I wouldn't really recommend using clouds as predictive tools over weather forecasts and weather maps, but it is still kind of nice to be able to look up and sort of know if you're looking at a rain cloud or not. So also just wanted to mention that cold fronts are more common in Australia than warm fronts, but I have included the warm front clouds because they do occur. They do occur in that sequence as well when they're associated with some other types of phenomena, like moisture in sort of upper level wind jets, and also with some other features like troughs. And that brings us to the last feature on the weather map we're going to cover. Troughs are elongated areas of relatively low pressure, usually represented by a dashed line, in this case blue, on weather charts. Now, like cold fronts, they separate two different air masses, usually one of moist air and one of dry air, and rain and storms can be generated along those boundaries as the dry air mass moves into the moist air mass, lifting it. Troughs can also be seasonal. In particular, every summer, we await the arrival of the monsoon trough in Australia's north, which brings an influx of warm, moist air from those warm equatorial waters above it. So here is a very good segue from weather into climate, because when we start to talk about seasonal cycles like the northern onset, we're moving from that weather domain into the climate domain. So this is a chart showing kind of characteristic time scales and spatial scales of weather and climate phenomena. Everything we've talked about so far sits in this area of weather on the scale of hours to days, and from a few kilometers in the case of storms to about 1,000 kilometers in size when you're talking about those big highs and low pressure systems. But the summer monsoon up north starts taking us into this scale of long range or seasonal scale climate. So here we're going to move into our next section, which is talking about some of these large scale drivers of climate in Australia. So I'm just going to take a sip of water too. So to start, Australia sits largely under a feature called the subtropical ridge. This is a belt of high pressure. It actually circumnavigates the globe between about 23 and 66 degrees south, where air tends to be descending. Remember, descending air tends to be settled, cool, dry, high pressure. On the south side of the ridge, these blue arrows, you have the westerlies, and while not drawn above the subtropical ridge, you would have the equatorial trade winds. But it is important to remember that our planet has a seasonal cycle, and these belts of winds and rising and descending air are actually moving north and south throughout the year. So that subtropical ridge is moving north and south across Australia. In our winter, so the diagram on the left here, all of our systems are shifted north towards the northern hemisphere summer. So the subtropical ridge sits right over the center of Australia. The southeast trade winds are dominating over the north, keeping those regions relatively dry, while the westerlies are passing over the southern part of Australia, throwing this frontal rain across that part of the continent. In our summer, everything shifts south. high pressure sits over the south of the continent. The westerlies are pushed further south, so we're not really getting as much frontal rain. And up north near the equator, that rising rainy component of the global circulation has shifted south and is being drawn into Australia by the monsoon trough that we showed earlier. And that's what's bringing our northern tropical wet season. So in addition to these fairly reliable seasonal cycles, we also have these large-scale global climate drivers that can affect climate on scales from weeks to years, and they can have fairly irregular cycles. They oscillate, but it can be a few years between phases. And today I'm going to focus on the El Niño Southern Oscillation, or ENSO, and the Indian Ocean Dipole, or IOD, due to their prevalence on both climate and on the news cycle. So for an overview on all of these climate drivers, including the Madden-Julian Oscillation and the Southern Annular Mode, and how they affect Australian climate, I really do recommend the Climate Dog series, which was co-produced by the Bureau, New South Wales and Victoria. Really great series of animations showing how these drivers affect climate with the use of herding dogs. So most people here have probably heard of El Niño and La Niña. It's kind of hard to avoid them in the news sometimes. They are part of the El Niño Southern Oscillation, which describes this pattern of ocean temperatures and wind patterns in the Pacific Ocean that vary roughly every 3 to 7 years and can have significant impacts on Australian climate. So normally in the Pacific Ocean, when ENSO is neutral, which is what I'm showing here, there's warm water off Australia's coast, and there's cool water in the Eastern Pacific off of America's coast due to the trade winds blowing west. What happens in a La Niña is that the easterly trade winds in the Pacific strengthen, and the water gets even warmer around Australia, which promotes more rainfall over the Australian continent. During an El Niño, those equatorial winds weaken or even reverse so that the water near Australia cools and that rainfall promoting warm water has shifted east towards the Americas. And this changes the circulation over the Pacific. So now that cool, dry air is descending over Australia and inhibiting rainfall in our part of the world. The Indian Ocean Dipole, or IOD, is a lot like ENSO, but it occurs in the Indian Ocean. It's sort of the same mechanisms, but just an ocean basin over. In its negative phase, warm waters near northwest Australia promote rainfall, and in its positive phase, rainfall is reduced due to these cooler than normal sea surface temperatures off the northwest coast. So the ENSO and IOD can be really strong influencers on Australian rainfall. And 30 years ago, even 20 years ago, that relationship was so strong that ENSO indices, measurements of the El Niño and La Niña, were used to statistically forecast Australian rainfall. But it is a little oversimplistic to say El Niño equals dry and La Niña equals wet, which is something that tends to happen a lot in the media. ENSO interacts with the Indian Ocean Dipole, it interacts with the Southern Annular Mode and the Madden-Julian Oscillation, it interacts with those high and low pressure systems on that weather scale, which basically means no two El Niño years are the same, no two La Niña years are the same. You have a tendency towards dry and wet, but there's other things happening that can change the way it manifests. Luckily, these days, with advances in computation, our dynamic forecast models have actually gotten much better and can forecast these drivers and their impacts with far more sophistication than the old statistical models. So when it comes to looking at upcoming seasonal rainfall or temperature, we really do encourage people to consult seasonal climate models. So let's talk a little bit about how those work. The Bureau of Meteorology and its international counterparts all run these large, complex models on supercomputers to predict seasonal climate. These models allow the ocean and the atmosphere, the land, and even ice, sea ice, to interact with each other. So, for example, the atmosphere over Australia is responding to what's happening in both the Indian and Pacific Oceans and the Southern Ocean at the same time, taking into account any IOD or ENSO-like patterns that are occurring. The rainfall and temperature outlooks that they produce for Australia are taking into account all these variables and more. So if you've ever looked at the seasonal outlooks from the Bureau of Meteorology, this image may look familiar. This is the probability of exceeding historical median rainfall for the upcoming 3 months. So it's important to remember this is not how dry or wet it's going to be, it's how likely it is to be drier or wetter than average. So more brown means higher chance of below average, not more and more dry. Unlike weather forecasts, longer range forecasts can't be as specific about rainfall amounts because small random changes can end up producing very different outcomes the further ahead that we look. And that's why long-term forecasts are expressed as probabilities. So how is the probability calculated? Well, the model isn't just run once. It can be run up to 100 times for each forecast issue. This is a figure showing a theoretical forecast. So these blue lines are representing these many different runs of the forecast from a single day. So on the left, you have that first day of the forecast, and you see the lines don't all start at exactly the same point. There's a little bit of spread to represent these kind of minor but realistic variations in the starting weather conditions. And all the way at the right, at some time in the future, in this case, let's say 3 months, you have the final outcomes of all these model runs. So most of the forecast runs are clustering on some solution in the center, and you have a few stragglers above and below. And this represents this range of possible outcomes that the model is predicting. So how does this translate to the information on the probability maps, the probability of exceeding median? What those maps are doing is saying, hey, we know that this is the usual rainfall that we get at this time of year, the historical median. What percentage of the model runs are below and above that median? So if 70% of the runs are above the median, you have a higher chance of 70% of exceeding the median, and you'll have more blue colors on that probability map. However, 30% of the forecasts are below median, and these are still realistic possible scenarios that can happen. If they do happen, the forecast was not wrong. It did predict that range of possibilities. It was just a slightly less likely possibility than exceeding median. And there's actually a lot more information in the ensemble of model runs that you can discover on the Bureau's website. If you click around, for example, you can look at what is the chance of the forecast exceeding a certain amount, 50 millimeters, 100 millimeters, or what is the minimum total you might receive that has a 75% likelihood, or what's the chance of extreme rainfall. Also temperature as well, min and max temperature on there too. So there's actually a lot of interesting information buried on the Bureau's site if you look a bit closer. And you know what? If you do not want to use the Bureau's model as your main source of information, that too is okay. It is useful to know that there are about a dozen or so of these international models. They work roughly the same way, and you can use whichever you want or all of them. None are 100% accurate, all have different strengths and weaknesses, and it's really not about picking and choosing the right model or your favorite model. Ideally, what we want to see is that all models are predicting similar patterns, kind of like they are here. You might have a few predicting a slightly higher chance of wetter than average. You might have a few that are neutral, but you don't have a huge spread in that outcome. And that can give us a bit more confidence in the upcoming forecast. So that pretty much brings me to the end of this section. As a short recap, Synoptic charts are a valuable tool for examining weather across Australia for the next few days. As a general rule, high pressure equals happy weather, low pressure equals lousy weather. The subtropical ridge is a seasonal feature of Australian climate that is associated with high pressure, and its seasonal movement tends to have a strong influence on how and where weather systems like fronts move across Australia. ENSO and IOD do play a very important role in Australian climate, as do a number of other circulation patterns. And this is why their impact on Australian climate is complex. It's important to consult the forecast models, which take into account current observations of weather and climate using very advanced algorithms. These outputs are expressed as probabilities, not certainties. So that covers the Weather and Climate 101 section of this webinar. Hope I've done that bit justice. There was a lot to cover. I'm looking forward to feedback on that. I am now going to pass over to Kim to talk more about the work we do in the Seasonal Conditions Program. Thanks, everyone.
Excellent. Thank you, Jen. Thank you for a very comprehensive and it's really, there is so much more detail that you can go into these things. So I hope that's helped answer a few questions from everyone online today. The purpose of the next few slides is just to run through some of the tools that we offer to help with that farm decision-making process. All of these tools that I'm showing you are all freely available and can be used as needed. They're also tools that your agronomist or your farm advisors can access. Stuff like Paul and LLS staff all have access to these tools as well. So, no one, if you need that extra bit of information, people are aware and can help you use them. So firstly, I just thought I would bring up, sorry, get my slides right. Our first tool is probably our most known or most popular tool is the New South Wales State Seasonal Update. So it's our core product and it provides information on current seasonal conditions for New South Wales. The update is designed to provide a summary of seasonal conditions, information, as well as interpreting the climate outlooks, which Jen mentioned, and also our own recently released drought forecast. It also provides a range of maps and information, including current monthly rainfall maps, temperature maps, frost maps. There's a whole range of different maps in there. It's freely available. You can use the link on your screen to access the update. And at the top of the page, you can click on the subscribe to the State Seasonal Update to ensure that you get the next update. We produce them once a month and the next one should be out this Thursday. Our next product, it's probably the product that our team is most known for, and that's the so-called drought maps, which are based on our combined drought indicator. So the combined drought indicator is calculated by looking at 3 underlying drought indicators of soil water, plant growth and rainfall, and looking at how those indicators are tracking over the last 12 months. The colours on the map will change depending if certain drought conditions are met. So basically, if all 3 indicators are high, so that's soil water, plant growth and rainfall, if they're all high, the combined drought indicator category displayed is non-drought or the green on the map. If one of the 3 underlying indicators falls below a set threshold, the region is categorised as drought affected. If all 3 fall below that threshold, the region moves to drought category. And if all 3 of those indicators are extremely low, some of the lowest on record, the intense drought category is used. So this method, it allows us to look beyond rainfall alone as the only indicator of drought, and instead it allows us to explore the effectiveness of that rainfall on plant growth and soil water. You can interact with the website by either zooming into the LLS region and then your LGA and your parish to view the current indicator values, or you can search your address and the map will zoom to your region. Below the map, we now also have a time series chart where you can see how the CDI and the underlying indicators change over time. A couple of key points about using the map is a snapshot in time. It changes daily, so we encourage you to look regularly. All the underlying data it's all on a fine gridded data, but it's all aggregated to a parish level. And we do this to help maintain landholder privacy. It's showing a 12-month aggregated data window. So we're comparing conditions over the last 12 months to all other previous 12 months. So because of this, it's not a tool that's designed to pick up short-term deficiencies in the system like flash droughts. Our third product is the Farm Tracker app. So Farm Tracker is a very simple mobile phone app that allows you to take and track seasonal conditions and changes to conditions on your property over time. So each time a report is filled in, a photo diary is created where you can add information about conditions of your farm. It's a great way to keep track of conditions, look back over time, particularly once you start building up your reports. All the reports are available on the app and also through a cloud-based website as well. I do get asked a little bit about privacy of the reports. So the information you submit is not shared. I can see your reports, but only as an admin. I use the reports to help me understand what's happening across New South Wales. I'm based up in Orange, so it's very difficult to know what's happening across the whole state. It's also used as a way to ground truth what the CDI map is telling me. It can also be used and allows me to flag regions that may be experiencing difficult times early. For example, if I see a lot of reports coming in from a particular region, I can look further and see if any further actions required. Things like getting in contact with Paul, for example, or his other LLS colleagues, and giving them a heads up that there's a lot of reports coming in a particular region, and there might need to be some further investigation. Or maybe it's notifying others in the department that the conditions are declining. So it's really that early warning tool. But that's it as far as individual records go. I don't share them with anyone. Anything I do share is regionalised at a much higher level. And I guess the fourth product that we have available is data services provision. So we have a portal called the Seasonal Conditions Information Portal, and on it you have access to a whole range of maps. So all the maps in the state seasonal update are in there. If you like playing with data, there's lots of spatial layers, downloadable data sets as well. We've also recently released a drought API, so you can see it in action through our collaboration with Federation Uni on the My Farm dashboard. Some of you might be familiar with the My Farm dashboard platform, so we have a card on there now that will load up the CDI information on that site as well. We can also be contacted for special requests. So now I just thought we'd give a quick, super duper quick look at the current seasonal conditions. All the maps that I'm going to show and more are updated each month in that state seasonal update. So firstly, just looking at our combined drought indicator map and the current conditions across New South Wales. So the combined drought indicator is showing that currently about 79% of New South Wales is in a non-drought category or a recovery category at the end, or very close to the end of February. Rainfall leading into autumn has been highly variable across New South Wales. For most of the state, summer storms have been effective in providing some relief from those warm temperatures and high evaporation rates. However, dry conditions remain, particularly in the south, including Riverina and Murray regions. We've been monitoring these dry conditions in the south of New South Wales for probably about 6 months now. If we have a closer look at the Murray region, we can see that most of the region is in that drought affected category, and the extent of that category has been expanding for several months now. Rainfall hasn't been sufficient to maintain any long-term productive conditions, recharge that soil moisture and build that long-term plant response. And unfortunately, without further rain, it's likely we'll stay in the drought affected category or possibly increase in the coming weeks. This map, it is really useful just to help understanding the current conditions, but it is just a snapshot in time. We always hear it's great information, but when will we be out of drought? We're always asked, when's the drought going to break? So over the past 3 years, we've been working on providing some insights into exactly that question. So we've recently released a drought forecast product. This uses the same process as used for the drought map, but instead it provides a forecast out to 3 months ahead. So the forecast consists of 4 map panel. And so firstly, we have the current CDI map that I just showed you. So we can compare the forecast with the current conditions. And then we have the forecast. So what is the CDI forecast for the next 3 months ahead? And so in this case, it is the CDI forecast for the 30th of April. The forecast is predicting for this this particular forecast is predicting that the most likely CDI drought status for the 3 months ahead is likely to remain as is in the Murray LLS region out to that 30th of April. We may see some areas transition into that recovery category by this time, but unfortunately things are likely to remain challenging for a little bit longer. The third map we look at is how confident we are in that forecast. And so this is our ensemble or model agreement map, and it looks at the certainty around the forecast. So for each forecast, we generate an ensemble of 99 possible outcomes, kind of like what Jen showed earlier with the variation in the model runs. So the darker the blue on the map, the more of the models agree on the forecast. So you can see that we have a high agreement for most of New South Wales and in that April forecast, noting that there are some areas with that lower agreement, and these can be seen in those lighter blue areas. And it's areas where you should be a little bit more cautious in using the CDI forecast. So although I just mentioned that parts of the Murray LLS region may be in the recovery category out to the end of April, there is lower agreement in the models on this outcome. So it means that there is more of a range of possible outcomes in those lighter blue areas. Our final map is the past skill map. So it describes how closely past forecasts for this period match with what actually happened. If a model has consistently provided accurate predictions, there is more confidence in that output. However, if the past accuracy is low, it suggests that there's probably a bit more need for a bit more caution in interpreting the forecast, especially when you also have low ensemble agreement as well. So together, both these bottom maps are used to describe the confidence that we have in that forecast. The next forecast, you can, those who are watching closely, you can see that we've got a end of February forecast for current to a April forecast. Our next actual run for the forecast, which will then take us out to the end of May, will be released this Thursday in the state seasonal update. So it's a new product. It's another one for the toolbox that can be used to help forward plan based on seasonal conditions. And just quickly over to the rainfall update. On the left is the rainfall totals received during summer, minus the 28th, so it's to the 27th of February. We report a monthly rainfall and year-to-date rainfall in the state seasonal update, but I thought there might be some interest in the summer rainfall. So we can see that rainfall totals over summer have varied depending on where you are in New South Wales. For the Murray LLS region, falls have been between that 25 to above 200 millimetres of rain with a clear gradient east to west. The figure on the right is a rainfall percentile chart. So what that is showing is whether rainfall over summer has been above or below median. So the blue colours show where rainfall has been above what is normally expected, and the red or orangey colours show where there are rainfall deficits. So again, focusing in on the Murray, we can see that in the east there has been near normal or a little bit above normal rainfall over summer, but we definitely do have those rainfall deficits present in the west. The seasonal outlooks are also available in the state seasonal update. They're also available every Thursday on the Bureau's website. The current rainfall outlook is for that near equal chance. It's a 50-50 split for most of New South Wales, whether we're going to be getting that above or below median rainfall. There's also a very high chance of exceeding minimum daytime and overnight temperatures as well. And just quickly on the climate drivers, which Jen mentioned earlier, there's not too much to report on at the moment. ENSO is currently neutral, and it's expected to remain so through to July at this stage. The Indian Ocean dipole is currently neutral, but it doesn't really have a strong influence at this time of year anyway. We start paying more attention to the Indian Ocean in late autumn. The southern annular mode is neutral. It's expected to stay neutral for the next week or so, but it's quite a volatile driver. It does change quite regularly. And the Madden-Julian oscillation is also weak, which means it has little impact on Northern Australian rainfall at the moment. So in summary, with the products and tools available, there's a lot of information available for you to use. It's really useful to look at a range of tools to help you plan and make decisions. And certainly by improving your understanding of the forecast, you're better armed to make those decisions. Weather forecasts, they're really useful in making those short-term operational decisions. The Bureau's forecasts or other forecasting tools, it helps give that picture of what is potential of certain conditions, making those longer-term tactile decisions, cropping or livestock purchases, sales, for example. The state seasonal update, a summary of information, much broader information on current seasonal conditions, used alongside things like Farm Tracker, just to help you build that personalised information specific to your farm. That's the end of our presentation today. So probably some take-home messages. I guess the synoptic charts, they're or the weather charts, are a very valuable source of information, but they are complex. Take the time to understand them. And there's plenty of information out there available, and looking at the news as well. Understanding cloud patterns is complex. Learn about the ones that are familiar in your area and use them alongside weather forecasts to help take some of that guesswork out of it. Understand probabilities and the chance of something occurring. Even if it's probably is very likely something will occur, it doesn't mean that it will. Don't rely on the media hype. The climate outlooks are the most reliable source of information on climate forecasts. Just because you hear El Nino on the news, it does not guarantee dry conditions. It's just one of the many players in the equation. I guess, and finally, there's a range of tools available, both free and user pays. So refer to them regularly, but don't make a habit of picking winners. You don't just select the ones that are telling you what you want to hear. Also, if it's a forecast that you're using, know its skill. If it tells you if a skill the skill that they put out should be able to tell you how accurate it has been in the past. Does it show confidence in the forecast? Forecasts that are provided without skill should be avoided. And finally, so we've got this in the webinar chat for you to go back to. There's just a couple of links and resources as well that you can refer to. And that is it from us.
Thanks very much, Kim, and thanks very much, Jen. I might, we've got a little bit of time, a couple of quick questions if anyone's got any. There were a couple in the chat that I think we addressed. Just let me have a quick look here. Oh yeah, Matt Kennedy had a question there. Are events like tornadoes predictable in Australia, or are they too localised? And do we technically have tornadoes? I was in a discussion with someone the other day about this.
Yep, I'll take that one. My knowledge might be a little bit out of date on this one, and also a bit US biased, where there are a lot of tornadoes, a tornado season, and where, as far as I'm aware, still very difficult to predict. Tornadoes do occur in Australia. They are far less prevalent than they are in the US. You can't really in either country predict, oh, a tornado is going to occur in this place in this time, but they do tend to be associated with severe weather. So those severe thunderstorms, those cumulonimbus clouds, people who are far more gifted at reading radar charts than I am can sometimes identify the feature that will spawn a tornado in the radar, the Doppler radar of a severe storm. Unfortunately, that's not a whole lot of warning, but it is actually heaps better than it used to be. So I hope that kind of satisfies that one as best I can.
Thanks very much for Jen. I just replied to a question from Bob. You're online there, are you, Bob? Yeah, the question was about the probe in the context of the farm tracker. Now, I know about the probes that are connected with the farming forecaster.
Yeah,
model.
sorry, Paul. That was, I realised after I wrote it, it was the farming forecaster probe.
I
yeah.
knew what you were talking about.
Oh, okay, yeah. Not sure on that one, Bob, but it's something I can follow up. I just actually had farming forecaster running off to the side there, and where we were the other day up at Burrawa, it is looking very nice. Even the farming forecaster compared to anywhere. And if people are familiar with farming forecaster, it's a good exercise to have a look at the models and the outlook maps that Kim was showing us there, and looking at those alongside the farming forecaster model. And there's a high degree of coincidence between those there, and that can help you get a little bit more localized in terms of your predictability and what's happening in your patch.
Yeah, sorry, Paul, I'll just jump in. Sorry. So yeah, so as Paul mentioned, we've also got a new product. It's only, I think it's been out once, so he must have released it last update. So it's a 21-day relative soil moisture map. So it just looks at those short. It's similar to what we do with the longer term, but just bringing it down to that 21 day. So it does pick up a lot of the differences in those soil moisture profile, and does have some relationship with the farming forecaster probes as well.
Yeah, that's excellent. Yeah, I mean, for those of you who don't know much about farming forecaster, just get onto your forecaster, get onto your search engine, dial it up, have a look, find your region on the map, and have a look. It's more specifically deals with some of the grass production, the pasture production, and the models associated with that. But if you have any queries on that, ask myself, or if you're in the southeast, Matt Lischke is your man, and if you're in the Riverina, people the likes of Michael Campbell, Jeff Minchin, and Martin Prius up there based out of Wagga can help you with that as well. Any other questions before we look to wrap up? No worries. Okay.
Oh, Paul. Sorry,
Yep.
Paul. It's Ash Pake here. You can't see me, but
thought it was you, Ash.
At Walla Walla. Just a question. So we're in the Greater Hume area, so in the Murray LLS, and I noticed on your maps you're showing there that we're forecast for heading into drought conditions through to April. Just a question about so does drought breed drought? So last year we seemed to be in a bit of a rain shadow and had a really tough season last year, and it seems like we're heading the same direction for the first half of this year compared to the rest of the state. Like, does drought breed drought in that we're pretty dry at the moment? Does that hot, dry conditions pushing air upwards? Does that push all these storms north of us or south of us?
I just have to think about that one a little bit, Ash. There is a certain aspect of persistence in drought, but I think that's maybe not quite what you're asking. The drought indicators are relative to your area. So if you were in an area that had a dry season, that drought would only show up if you were actually even drier than usual. Certainly, some of those seasonal cycles that I talked about, the position of the subtropical ridge, the position of those are not set in stone. It's not coming down to 30.689 latitude every year. There's variation in that. That's what's captured in some of these other climate drivers. But those are currently neutral for the most part. So if you're in a rain shadow and you have topography, then that would be something that showed up consistently. I think really in that area, you just are on the edge of drought. You just haven't gotten, you've been getting actually some average rainfall, but not enough to pull it out So yeah, you do need a certain amount more rainfall to come out of a drought. It's a lot easier to stay in drought, and that's just that natural persistence.
Yeah, I
like
think
to
it's
give
that's
like our rainfall events are just like we've had some summer rainfall events, but the distance, the timelines between rainfall events, like it's gone now. Like we're in a dust bowl at the moment. Whereas Wagga and north of Wagga seem to be catching these 100 mil rain events. But they just seem to be pushing either north of us or sliding south into Victoria for some reason. And it just seems like we're shaping up to a similar weather pattern that we had last year, where the distance and the time between rain events was just too much. It got to a point, where in September we had to cut crops for silage because they were too far gone. There was not enough soil moisture to get them through. So, whereas we're normally a very reliable area, like we're only 30 minutes north of Albury, like between Albury and Wagga, we're normally a very reliable area. For some reason, last year and this year, we seem to be, looks like we're going to miss out again. But
yeah, it's so tricky. You just don't know when, your neighbour down the road gets that storm that just sits over the top of them and dumps those huge amounts,
Yeah.
and you miss out, or vice versa. It's really tricky.
But
Yeah,
then,
go.
like Elders weather forecast, like the 12-month Elders weather forecast is showing above average rainfall through to September, which is quite surprising.
Yeah, and it's tricky too. We only go out to 3 months. There's just more reliability in that forecast. The longer you go out, the more, the more variation there's going to be. You can use it as a guide, but I wouldn't be, betting the house on it.
Yeah, but I think the 3 months, like I've spoken to Paul about this with some of the drought stuff, like the 3 month window is a really critical decision making. Like trying to make decisions 3 months in advance is really important, and having strategies so your forecast out to April is really useful, because it's like, if it hasn't rained by this date, then I'll pull the pin on canola and go barley, or I'll have to make some decisions about lambs and how do I keep feeding lambs, or do I cut my losses and actually offload some stock? So the 3 month window is a really important window.
Yeah, it's spot on. There's another workshop that we do with farmers. We look at all of the maps and more, and then go, okay, so for example, think about where you are now, regardless of whatever, but think about where you are now. Okay, you're going to get potentially average rainfall, soil moisture's shot, the forecast isn't looking good. What does that mean? What are the decisions that you're going to need to make? If you get average rainfall, is that going to be enough? Probably not, to pit you out and get those production conditions happening. So what decisions do you need to make? Which is why, people like LLS, agronomists, all of that are really good in just having those discussions and help with that planning.
Yeah. Thanks, Ash. You raised a good point there in terms of your point of decision making. And Bob was at a workshop last week and the week before where we talked about drought and dry conditions. At what time do you start making decisions? And some people have it mapped down to the date on the calendar, like the 31st of August. If this happens or these conditions prevail, this is what I'm going to do. No questions asked, because that's the plan I've made in the cool light of day. And that's the sort of thing. And your comment there, Ash, that if things go the way they are, you've already dropped off the canola option, and you're looking at for another option there. You have a few options given a certain set of conditions, and that's the sort of advantage you can have in using some of these predictive models. It can give you an idea, a little bit of an insight into the future, far and away greater than our predecessors had 40 or even 30 or 50 years ago. So we're spoiled in a little bit, I think. So all good information to use there. I'm just mindful of the time. Thanks for your question too, Ash. And so I might just share my screen and wrap up the evening. I just wanted to firstly thank everybody for coming along tonight. I know it's the first day of the week and there's probably plenty on your cards already. And I just need to acknowledge that the webinar's hosted by the Murray Local Land Service, but it's really encouraging to see that a lot of people from other regions across the southeast of New South have dialed on tonight. So that's great. People like Bob and others in his neck of the woods. The recording will be available over the next week or so once I get the media and comms people to do whatever they do to it and put it up. I shall then send that link to all you folks. In that sort of time frame, also, I'll try and send out a feedback survey. And as Kim indicated at the start, they're keen to get your feedback on this style of webinar with respect to the content and what is dealt with, whether the front end with all the basics on the weather map, which I found fantastic. There were things on there that I wasn't aware of, which have been great, and I consider myself a bit of a weather map nerd. So that feedback should go out. So please respond to that. And last but not least, I want to thank Jess Armstrong from Holbrook Landcare Network for riding shotgun on the tech side of things tonight to help us out if things didn't go as planned. So I might leave it at that, and thank you all very much for coming along. And Jess, at some point we can probably stop our recording and retire to our green room, I suppose. Thanks, everybody. Thanks, Bob.
Thank you, everyone.
Thanks, Ash. Cool.